Hello students, this is Shweta Patil and I welcome you all to the video lecture on computer organization. We are dealing with second module, input-output organization, and today in this video I will be explaining you about the basic concepts of interrupts and different methods in which interrupt handling will be done. So, in the previous topics we looked that whenever input and output transfers are to be done, input output data transfer is to be done, the processor will be waiting. Okay, that input output data transfer, how it is done? By program controlled IO, isn't it? So there the processor will be continuously checking the status bit. Which status bit? S in and S out. These are the status bits with respect to keyboard and display, isn't it? So processor is not doing any useful work, but it is continuously monitoring the status bit of the devices. So the useful time of the processor is wasted there, and hence the processor performance will be reduced. So what we did is move to an approach called as interrupt approach, wherein any of the input device or the output device will be intimating the processor about its input and output operation. That is, whenever an input is ready or output device is ready, it will be sending an interrupt. It will be sending a hardware signal to the processor. That hardware signal is called as an interrupt to the processor. So this is sending the interrupt signal on a line called as interrupt request line. That's why an interrupt request line is dedicated for this purpose. Okay, so processor will be performing other useful work when the device, either input device or the output device, becomes ready. At that time it will be sending the signal through the input interrupt request line to the processor, and at that time the processor will come to know about the device is ready. Till that time it is performing its own operation and it's not wasting the time. So now let's look at this. Consider a task where some computations are to be performed. Okay, I am having a program, okay, where computations are performed and results are to be printed on the printer. Okay, so we use two routines. One is computing and the other is print routine. So first computing routine will be executed and then print routine will be executed. Here, as the printer is a slow device, it slowly prints the data. Until that time, instead of the processor wasting its time by checking the printer whether the printer is ready or not, the device will be made to intimate the processor here. How? By waiting the processor, if it is waiting for checking the printer's status, then it decreases the performance of the processor. So the concept of interrupting the processor came into existence. Okay. In this example, the processor is executing the main program, and when the printer becomes ready, it sends its interrupt request on interrupt request line, a dedicated line called as interrupt request line. On that line it will be sending a signal. Upon receiving the interrupt request, the processor will stop whatever it is executing. Okay, what it is doing, the processor will be stopping whatever it is doing and moves to the interrupt routine of the printer. This routine executed in response to the interrupt request is called interrupt service routine. Which routine? The routine which the printer wants to execute by intimating the processor. That routine is called as interrupt service routine. Here you can see the processor is executing, okay, first, second, third, all the instructions are executed and it is executing ith instruction. At that time, what happens is an interrupt has occurred. It is shown by an arrow mark. Interrupt occurs at ith instruction. Then what the processor will do? Processor will complete the execution of ith instruction. It will complete whatever it is executing. So ith instruction it will complete. Then it comes to know that yes, some request is there. That's why what it will do? The return address, that is the address of the next instruction, is i+1. That will be saved onto the top of the stack. The i+1 where it will be there in PC, isn't it? So the content of PC will be moved to the top of the stack or in the link register it may be. Then after saving the content, that is return address, it immediately move to the interrupted service routine, that is the printer, the program of the printer. There it will execute all the instructions. Okay, what it will be doing? It will be executing all the instructions. Maybe the first instruction may be disabling of the interrupt, and the last instruction, which is return instruction, before that we could have enabled the interrupt. Okay, so what it does, it executes ith instruction. Upon receiving an interrupt, it executes whatever it is presently doing, saves the content of the next instruction so that it should return to the same point, then move to the interrupted routine, interrupt service routine, executes the routine. At the end, the last instruction will be return instruction. So after executing return instruction, it will collect back the content of top of the stack onto the PC or the link register onto the PC. Thus it's come back to I+1 instruction and executes the remaining program. This is how an interrupt will occur. Okay. Now let's discuss about what hardware arrangement is there. See, as you can see, the processor is getting an INTR request. Here you can see INTR is there, right? You are having one line called as INTR bar, to which all the device switches are connected. Assume that we are having some devices, 10 devices are there. Okay, D1 till D10, all these devices are connected to INTR line, interrupt request line, through the switches. Okay, you can look at the switches. And this INTR line is connected to VDD through pull-up register. So the normal voltage on the INTR line will be VDD if none of the device has requested. That means if all the switches are open, then the voltage on INTR is equal to VDD, which may be 5 volts, assume, which is high. INTR is high. If INTR bar is high, then any request, is it that any request is there for the processor? INTR is nothing but opposite of INTR bar. Okay, that's why the voltage on INTR bar line is high, it is 1. What is got to the processor is 0, because it will be inverted, isn't it? So when no device requests, then all the switches will be open and the INTR bar will be high. At that time, no interrupt request will be sent to the processor. Now assume that D2 sends an interrupt request. When D2 is the device which is connected to INTR2, assume, at that time it closes its switch. When the switch is closed, INTR2 switch is closed, all the voltage VDD will be flowing towards the ground and the INTR bar line becomes 0. The voltage at INTR bar becomes 0 instead of high. Now this 0 is inverted and that is got as INTR, which is 1. Now interrupt request has been sent to processor. Why it has been sent to processor? Because device 2 has requested by closing its switch. This is how any of the device can carry out an interrupt request towards the processor. If more than one device's request, then it will be taken as INTR bar is equal to INTR1 or INTR2 or INTR3. Likewise, this will be calculated. So if many number of devices have requested, then also a single request will be sent. If one device has requested, then also a request will be sent. Okay, this is how an interrupt arrangement is done, and many number of INTR bar lines may be there for a processor. It's not that only one line is there and many devices will be connected. Many number of lines, such lines may be there. Okay, now handling, enabling and disabling the interrupts. What is this? Let's look at the scenario. What happens when an interrupts are there? Interrupts are enabled. So what happens at that time? You can see the device will raise an interrupt request. If interrupts are enabled, then the device will be sending an interrupt request. Then what happens? The processor interrupts the program currently being executed. It stops whatever it is doing. The processor will stop whatever it is doing. Then it saves the return address. Okay. Then interrupts are disabled by changing the control bits in the PS. In program status, by changing the contents, control bits, okay, we are disabling the interrupt. Why we are disabling? So that no nested interrupts come from the same device, or else the other device are not allowed to send an interrupt request by disabling, okay, because already one is interrupted, okay. Now after disabling, the device is informed that its request has been recognized, and in response it deactivates the interrupt request signal. An acknowledgement signal will be sent to the interrupted device, and upon getting an acknowledgement, the interrupted device, the device which has sent the interrupt will deactivate the interrupt request signal. Then what happens? The action requested by the interrupt is performed by the interrupt service routine. The processor will execute the interrupt service routine, okay. Then at the end of the execution of the routine, again the interrupts are enabled and execution of interrupted program will be resumed, okay. So these all are the steps what happens when an interrupt occurs. All these are the steps which will be happening. Now the question is, assume that a single device has sent a request, okay, it has sent a request on INTR, and the processor is going to execute the interrupt service routine of that device, but the device has, the case may be the device has not yet taken out the request from the request line. It may lead to the nested interrupts. Already the processor has got an interrupt request from device, assume device 1. Device 1 has sent an interrupt request. Upon getting interrupt request, the processor is executing the interrupt routine of the device 1. But then what happens is, device 1 has not yet removed the request, okay. That request may be considered as infinite requests, and the processor may go on executing them. We have to make an arrangement so that it will be disabled. So what possibilities are there to solve this problem? The first possibility is to have the processor hardware ignore the interrupt request line, okay. How it will be ignoring the interrupt request line? After execution of the first instruction, the interrupt service routine will be ignoring it, okay. The interrupt disable instruction will be executed as the first instruction in the interrupt service routine. What is done? Yes, the device has requested for an interrupt and processor is ready to execute. So it goes to the interrupt service routine, start to execute that interrupt service routine. The first instruction of interrupt service routine should be disabling the interrupt. So that will be executed. Upon execution of that, the processor will be executing the rest of the instructions, and all the other devices interrupt requests will be disabled, or the device 1 itself, multiple requests from that will be disabled. How? By executing the first instruction of the interrupt service routine as interrupt disable instruction. Now it will execute all the routine instructions. At the end, before returning, it will be executing one more instruction called as interrupt enable instruction, okay. So before leaving the interrupt service routine, after completion of interrupt service routine, again all the devices interrupt requests are enabled so that all the other devices can now interrupt, okay. This is one possibility. The second option is to have processor automatically disable the interrupts before starting the execution of interrupt service routine. Automatically enabling and disabling will be done by the processor itself, okay. That is second option. Then what is third option? The third option is interrupt handling circuit will be there. It will respond only to the leading edge of the signal. Assume that edge triggered. If the line is edge triggered, then what all requests come during the rising edge of the signal at that time, only those interrupts will be considered, else no other interrupts are considered. So this is how the problem of repeated execution or disabling of the interrupts will help out, okay. Next is about handling multiple devices. In handling multiple devices, let me show you. We have different things as polling, vectored interrupts, interrupt nesting and daisy chain. We will be looking through the circuits. See this circuit, handling multiple devices. I am having many devices, device 1, device 2, device 3 till device P. There are n number of devices, and each of the devices are having their own interrupt request and acknowledgement lines separately. INTR1 is there, INTA1 is there, likewise INTR2 is there, INTA2 is there. So it continues from first device to nth device. All the devices are having their own interrupt request and acknowledgement lines. Now what is happening in is, assume if device 2, only device 2 has an interrupt request. If only device 2 requests for the interrupt, then what happens? It will send a signal on INTR2 bar signal to the processor, and upon looking at the interrupt request, what the processor will do? It will hold whatever the return address is and comes to execute the interrupt routine of device 2 by sending an acknowledgement signal INTA2 to the device 2. No problem under such condition. If multiple devices request, assume device 2 and device 4, these are the two devices which are interrupting now. They send the interrupt request on separate lines. The processor will get to know, yes, it is having two requests. At that time, which one has to be served? That depends on priority arbitration circuit. One circuit is there which is priority arbitration circuit is there within the processor. It will be giving priority to the devices. Assume device 1 is having high priority, device 2 second highest, device 3 third highest, device 4 fourth highest. Likewise, priority goes on decreasing from 1 to n devices. Okay. So which is having high priority? 1, then 2, then 3, then 4, likewise. So if device 2 and device 4 are requesting for the interrupt request for the processor, then the priority arbitration circuit will solve the problem. That is, device 2 is having high priority than that of device 4. That's why the processor will go to serve the device 2 upon priority arbitration circuit. It will be first executing the that is interrupt service routine of device 2. After completion of device 2, it moves to device 4. This is how the priority arbitration circuit will help out to handle the multiple devices. The other scheme we can look at to handle multiple devices is polling scheme, wherein the processor is connected with one line called as INTR, and we are connecting all the different devices 1 to n through interrupt acknowledgement, that is INTA. Okay. So now the same example, assume device 2 alone is sending an interrupt request INTR. So if device 2 has sent INTR request, what happens here? The processor will be getting to know, yes, a request is there, but will it come to know which device has interrupted? No. Only it will get that interrupt request is there. Then it sends an acknowledgement. The processor is sending an acknowledgement called as INTA. Where it will reach first? INTA will reach device 1. Device 1 checks out whether it needs interrupt, whether it has sent an interrupt request and whether it needs the processor. If yes, it will keep it, execute the routine and then give back. But now device 1 don't want, that's why this acknowledgement line will be sent to device 2. Okay. So device 2, as it has interrupt requested already, then the acknowledgement will be taken by it and the address of the routine will be kept by device 2 only. That's why device 2 is having high priority than that of device 4. That is how connections are one after the other, which all are connected serial, the sequence, in the sequence manner the execution of multiple device routine will be done. Okay, this is daisy chain. Then combination of both, that is daisy chain and the priority arbitration. Here you can look at device 1, device 2, device 3, many number of devices will be there which will be connected to INTR bar 1, and acknowledgements will be sent through INTA1. Okay. Then you have one more such set, INTR 2 bar INTA2, likewise INTR P bar INTAP. So many number of rows will be there, and in each row many different devices are connected in a daisy chain manner. So if in the first line device 1 has requested an interrupt through INTR bar 1 bar, and assume device 1 of second row also has requested an interrupt. Among the two, as both are from first category, as both are belonging to the first device, both are the first devices of the row. Which among the two is to be executed? The processor already has given the priority to these lines. INTR 1 bar is having high priority, INTR 2 is having high priority, 3 is having high priority. Likewise, depending on the priority, that device will be executing. So, this is about how to handle multiple devices. In the next video, I will be explaining about DMA. Thank you.